Okay, here's a little bit of help with the discovering the rules of differentiation. I want to go right to the back page, and I want to talk about questions 25 and 26. So if you haven't figured out the shortcuts yet, here they are. All right, so if you have a function that's made up of adding or subtracting two functions together, you can just find the derivative of the first one and add it to the derivative of the other one. And it doesn't matter how many you have added together, that's all you got to do. Just find the derivative of each part and add those together. So here's a perfect example. F of x is made out of really 4 functions. These are 4 functions being added together. So all I have to do is find the derivative of each one. So the derivative of 8x cubed, well, I take the exponent and I multiply it by the coefficient. So that gets me 3 times 8 is 24. And then I have to minus 1 from the exponent. And then the next one, 2 times negative 2 is negative 4. And then minus 1 from the exponent. 2 minus 1 would give me 1. I don't have to write the 1 because x to the first is just x. So I'm going to erase it because it's more normal not to write the 1. And then the next one, the invisible exponent is a 1. So 1 times 5 is 5. And then 1 minus 1 is 0. And x to the 0 is just equal to 1. So the x just disappears. And then the derivative of a constant is 0. Okay, because the slope, if I was to graph y equals negative 11, that would just give me a horizontal line, and the slope would be 0. Okay, so here is the answer to number 25, and this is like the little formula for it. So we're just taking the derivative of each piece, and that's it. All right, number 26, we got to remember how to rewrite negative and positive exponents. So when you have a fraction, you can move what's in the denominator up to the numerator by changing the sign of the exponent. So right now, the invisible exponent, zoom a little bit, the invisible exponent on my x is a 1. So I want to move this to the numerator, and when I do that, I get x to the negative 1. So I can rewrite this, f of x is equal to 6x squared plus 5x to the negative 1. Now I can just take the derivative like I did on the previous problem. So 2 times 6 is 12. 2 minus 1 is 1. And I don't need to write the 1. Okay, the next one, negative 1 times 5 is negative 5. Negative 1 minus 1 is negative 2. So be careful with those negative exponents. Remember, you're subtracting 1 from it. So here is my derivative. Now, when you do this in math space, this is going to be in some assignments in math space. When you do this in math space, you now need to rewrite it with a positive exponent. So this part right here needs to go back down into the denominator. Put it back where it came from. So I'm 12x, that just stays the same, minus the 5 is in the numerator. But now, to make the exponent positive, I'm going to put it in the denominator, because a negative exponent means divide by x twice. So I'm dividing by x 2 times. There it is. Okay, so that is the answer to 26A. Okay, 26B, I'm going to rewrite my radicals as fractional exponents. So the first part here is 3x, and square root, the way you write that is as 1/2. Then that's minus 6x, and the third root is 1/3. Okay, so when you have an exponent, the denominator is the root. So if it's a square root, it's a 2. If it's a cubed root, it's a 3. If there was a little 4 there, it would be 1/4. Okay, now we're going to take the derivative. So 1/2 times 3 gives me 3/2. And then x, and then 1/2 minus 1. Okay, I'll do that down here. 1/2 minus 1. Well, 1 is the same as 2 over 2. So 1 minus 2 is negative 1. So that's negative 1/2. And then this one, 1/3 times 6. For those of you who have difficulty with fractions, 6 times 1/3. Put the 6 over 1. Oops, can't see that. I get 6 over 3. 6 times 1 is 6. 1 times 3 is 3, which gives me 2. 1/3 of 6 is 2, so minus 2x. And then I got to do 1/3, do my exponent. Oops, where am I? Minus 1. Okay, I can rewrite that as 3 over 3. So 1/3 minus 3/3 gives me 1 minus 3 is negative 2 over 3. So when I took the derivative here, this ends up being negative 2/3. Okay, again, you're going to be doing this in math space, and math space wants you to rewrite this with positive exponents. So if I rewrite that with positive exponents, I'm going to have this x to the negative 1/2 is going to move to the denominator. So 3 is in the numerator, 2 is already in the denominator. I'm going to put the x to the 1/2 right next to it. And then over here, the 2 is going to stay in the numerator, and this is going to move to the bottom, so x to the positive 2/3. So here it is, written with positive exponents. Now, if I wanted to change it back to radical form, I could also do that. So I'm running out of space. Let's bring it over here. So f prime of x, I could rewrite that with radicals. This would be 3 over 2 radical x, because x to the 1/2 is the square root of x, minus 2 over, and then this one, the x is being squared. See that the numerator is what it's the power is, and then the denominator is what the root is. Bam. So there it is, written back in radical form. Okay, so for math space just wants positive exponents, so it would accept this. That would not be a problem. But if you want to be even fancier, you can do it like that. Okay, so you're going to need that to be able to do that for some of the math space problems. Okay, good luck.